All right, so what is this, 4.6? Is this 4.6? Okay, 4.6 in Foundations Math 30. This is number 17. So we're trying to figure out how we can use the combination formula to determine the number of diagonals of an n-sided polygon. So we're trying to generalize, we're trying to discover some kind of pattern and figure out how we can use this formula to predict, right, how many diagonals there would be in any polygon of n sides. So we kind of want to use, I guess, n as an unknown, and we want to build a formula from that. So this is what I would take from these diagrams here, right? So if we have n here and then diagonals here, okay? So what do we have here? How many sides of this do we have? How many sides here in a triangle? 3, right? How many diagonals? So diagonals would be the lines that you can draw from any vertex to another vertex without scaling one of the actual sides. So here there is no other point that is not one of the sides. So 0. Here, this is a 4-sided figure now. And we have, so this, we can draw a diagonal, no, not to this one, but over here, yes. And this one can, over there. So we have 2. Okay. So we're just assembling this. This is a pentagon, 5. So how many do we have? We have 1, 2, 3, 4. Is that 4? 1, 2, 3, 4, 5. There's 5. So what is it, 4 or 5? 5? Okay. It's 5 different lines there. Okay, good. Just checking. And what about this one? Is this 6? Okay. And we have 6 and 9. Did you say? Okay. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Good. Okay, 9. All right, so that's all we've got so far. We could draw some more, but I don't know if we need to. We probably have enough to go on here. So we've got n and we've got d. So we have to determine the number of diagonals. So it's going to be something equals d. That's what this says. So now whether we stay that way or not, that's what I would do. So how can we use n in some kind of combination formula? So we're going to use n and what to find d? So the number of sides, so so 3 has to get to 0. So we could do n minus 3, but that doesn't use the combination formula, and I don't think that works for the other ones, right? Look at 5 minus 3 is not 5. Okay, so it's not this one. So the combination formula would be like NCR, right? So could we do n and then c and then some number, or n and then c and then what, n minus 1 or something? Like, how could we use n and build a combination formula using combination to get to d? So let's just try something. So let's say you did n choose 1, okay, equals d. Does this work for all of these that we have here so far? So 3 choose 1, what's that? You have 3. No, that's going to be what, 3? No. So that doesn't work. So it's not this one. Okay. So this isn't going to work. N choose 1. So do we have to adjust this n? Do we have to go n plus 1 or n minus 3 or n minus, I don't know. So what's here and what's here? Can we build something that matches all of these numbers? And that's kind of what you're trying to figure out. So you could just trial and error things, you know. I don't know, 3, 0. So 4, 2, 5, 6, 9. So is this kind of the way you tackled this? And did anyone come up with some ideas? Now, I know some of you looked at the back of the book and kind of went from there and decided that makes sense. But is this a good way of trying to tackle this? Discussion. All right, so what we've done, I've asked you guys to take a few moments to try just some different things. Here's an example. Like, let's say that we want to use n and the combination formula here to find d. Let's see if this works. So what you would do here is you would try, okay, 3 choose, what's n minus 1? Well, that's 2. So 3 choose 2. So what's 3 choose 2? I'm going to need you guys to help me out here in figuring this out. So what's 3 choose 2? Because it takes me too long on this calculator, really. That's 3? Okay, so it's 3. So that's not diagonal, but yeah, I don't know, but it's close. I mean, I guess we could subtract 3. What if we did this? Would that work? That would work. Then that would give us 0. Okay. So let's try it again for another one. What about this one? 5, choose. So if I tried this again, this would be 5, choose 4. Actually, this would be a plus 3 over here. It would be minus 3 on this side, right? So 5, choose 4 minus 3. Does that equal 5? Diagonal 5. So what's 5, choose 4? What's 5, choose 4? 5. Minus 3 is not 5. Okay, so we might be close. We might not be close. We might have to change this. We might have to change this as a 3. I don't know. We could have a solid number or something like a 1 or a 2 or a 3 here, which could work for all of them. So yeah, just kind of trial and error and see what works, and you may have to try a few things. I mean, if you try something like this, okay, if you choose 2, that kind of worked, and we subtracted 3, but that wasn't really any good. So if we subtracted like n or something, then that works because it's 3 choose 2 minus 3 is 0. So let's see if that works for 4 choose 2 minus 4. So what's 4 choose 2? Okay, 6 minus 4. Oh, that actually works. Or sorry, the 4 here. 4 and 2. So what about n? So what about 5? Choose 2 minus 5. What's 5 choose 2? 10 minus 5 is, 5. Look at that. So now we're on to something. So it'd be basically like trial and error. And you might have, if you were doing this sort of properly, you would have like a half a page filled up with all your trial and error and your work and stuff. Right? Something like that. Which is fine. You want to run through it. Okay, questions? So it looks like we have this as our formula for 17.